cleaning agent has two, which is soaps and detergent. First of all, I will talk about soap first. Soap are sodium or potassium fatty acid salts. Soaps are produced from the neutralization reaction between fatty acids and alkali. Fatty acids are long-chain carboxylic acids. Sources of fatty acids can be obtained from natural ester in animal fats or vegetable oils. The general formula for soap is RCOO-Na or RCOO-K+. R is an alkyl group usually containing at least 8 carbon atoms. However, this alkyl group usually contains 12 to 20 carbon atoms. R consists of saturated or unsaturated hydrocarbons. The example of soap has two, which is sodium laurate and sodium palmitate. Next, I will talk about detergent. The production of detergents began during the Second World War owing to the lack of animal fats and vegetable oil. Detergents are non-soap cleaning agents. Detergents also are sodium salts or sulfonic acids. Two types of sulfonic acid used to make detergents are alkyl sulfonic acid and alkyl benzene sulfonic acid as shown in this slide. Detergents are also usually made from synthetic sources such as petroleum fraction. The example of two groups of detergent is sodium alkyl sulfate and sodium alkyl benzene sulfonate.
Okay, next is preparation of soap. Soap can be prepared from natural sources through hydrolysis of oil or fat in sodium hydroxide, NaOH, or potassium hydroxide, KOH solution. This reaction is called saponification, which is the process of hydrolysis of oil or fat by alkalis. Oil or fat, which is concentrated alkali to produce glycerol and fatty acid salts, which is soap. Okay, you can see the general equation of saponification reaction is oil or fat plus with concentrated alkali produce soap and glycerol. Okay, now oil and fats are natural ester known as triglyceride. Alkaline hydrolysis on triglyceride will produce glycerol and soap, which is salt or fatty acid as shown in figure 5.2. Oil or fats will plus with alkali, which is 3NaOH, and produce glycerol and soap. This is a chain hydrocarbon. R1, R2, and R3 are long chain hydrocarbon. It may be same or different. Okay, then we go to the preparation of detergent. Detergents are usually made from petroleum fraction and sulfuric acid, which is H2SO4. In this preparation, it goes through two processes, which is sulfonation and neutralization. So we go through the preparation of sodium alkabenzene sulfonate. Okay, sulfonation of alkabenzene, which is alkabenzene react with concentrated sulfuric acid, which is H2SO4, form alkabenzene sulfonic acid. In this picture, we can see alkabenzene plus with sulfonic acid will produce alkabenzene sulfonic acid plus H2O, which is water. For neutralization, alkabenzene sulfonic acid will neutralize by sodium hydroxide and NaOH solution to produce alkabenzene sulfonate salt, which is detergent. Okay, you can see at this picture, which is alkabenzene sulfonic acid plus with sodium hydroxide, which is NaOH, will produce sodium alkabenzene sulfonate plus H2O. Preparation of sodium alkyl sulfate. Sulfonation of alcohol is a long chain alcohol react with concentrated sulfuric acid H2SO4 to form alkyl sulfonic acid. We go to the neutralization. Neutralization is alkyl sulfonic acid will be neutralized by sodium hydroxide NaOH solution to produce sodium alkyl sulfate, which is detergent. Okay, we can see alkyl sulfonic acid will combine with sodium hydroxide and produce sodium alkyl sulfate plus H2O, which is water.
So now I will describe the cleansing action of soap and detergent. First, adding soap or detergent into water will reduce the surface tension of water. This increases the water's ability to wet the surface of the cloth. Second, soap or detergent will ionize in water to produce free-moving soap anions or detergent anions. Third, the hydrophilic parts of soap anions or detergent anion dissolve in water. The hydrophilic parts dissolve in grease. So now I will describe the cleansing action of soap and detergent. First, adding soap or detergent into water will reduce the surface tension of water. This increases the water's ability to wet the surface of the cloth. Second, soap or detergent will ionize in water to produce free-moving soap anions or detergent anions. Third, the hydrophilic parts of soap anions or detergent anion dissolve in water. The hydrophilic parts dissolve in grease. So next, movement of water during scrubbing and agitation causes grease to pull away from the surface of the cloth. Then, the hydrophilic parts of soap anions or detergent anions surround the grease. Grease floats to the surface of the water. Lastly, grease will break into small droplets. The small droplet will not reattach to the surface of the cloth due to the repulsion of negative charges of the hydrophilic parts on the surface of the grease. The droplets are suspended in water, forming an emulsion. Rinsing with water causes the surface of the cloth to become clean because the grease droplets are left in the water.
So next is comparison of cleansing action of soap and detergent. First is hot water. What is hot water? Hot water is water containing calcium ions and magnesium ion. Next is soap and ions combined with the cation to form insoluble soap, which is called scum. There is some equation to show that how a scum will form in a soluble salt. First, the stearate ion react with the calcium ions and become the calcium stearate, which is a scum. Next is we have stearate ion react with the magnesium ion and become the magnesium stearate, which is a scum. Next, the formation of scum causes wastage of soap because more soap will be needed for the cleansing action. Okay, next is detergents and ions also combines with the cation to form soluble soap in water. This is about detergent and the previously is about soap. Next, therefore, the effectiveness of the detergent cleansing action is not affected by the hot water. In this case, they also have some equation to show that how it will form. This detergent anion react with the calcium ion or magnesium ion to produce calcium salt and magnesium salt, which is those is a soluble salt. Okay, next is comparison of effectiveness of cleansing of soap and detergent. For number one, for aspect effectiveness in soap water, for soap, effective as cleaning agent. For the detergent, effective as cleaning agent too. For the second aspect is effectiveness in hot water. For soap, less effective due to the formation of scum, but for detergent, more effective because no scum is formed. For the third aspect is effectiveness in acidic water. For soap, not effective due to the formation of insoluble organic acid, but in detergent, effective because the organic acid form is soluble.
Okay, next I'm going to talk about the additive in detergent. So most of cleansing agents are detergent. There are various types of detergent with slightly different cleansing qualities. These differences are due to the additive in the detergent. Lastly, the additive also gives the special properties to the detergent. This is the example of additive that is being used in the detergent. So number one, we have biological enzyme. The function is to remove protein stains such as blood. For example, amylase, protease, and also lipase. Next one, we got whitening agent. The function is to change the dirt to colorless substance. Example is sodium perborate and sodium hypochlorite. Next, we got optical whitener. Is to make the clothes become whiter and brighter. For example, we have fluorescence dye. Next, we also have water softener and builder. The function is to enhance the effectiveness of the detergent by softening the water. For example, we have sodium tripolyphosphate. Next one is foam control agent. This is to control the foam formed by the detergent. For example, is alkali monotanolamide. Then we also have the anti-suspension agent. This is to prevent the removed dirt from depositing to the clothes. The example is sodium carboxyl methyl cellulose. Next one is fragrance, to enhance the fragrance of the detergent and fabric. For example, we have jasmine and also lavender. Lastly is drying agent, to ensure that the detergent powder is always dry in its container. For example, there is sodium sulfate and also sodium silicate.